Here we have what's known as a net of solid or nets of solid. So for example, we have this 3D object here, so it's a rectangular shaped 3D object. Now we can see that we have some dimensions here mentioned on it in centimeters. Now if we were to take this object and we were to imagine it was like a cardboard box and we were to kind of flatten it out like so, this here is what's known as a net of solids. Okay, or nets of solid. So you could take this flattened down, let's say cardboard box for example, and you could reassemble it back into its 3D solid. So you can go back and forth between these. So this is the area of nets of solids. So for example, this is a net of this solid here. So what this net of solid does is it makes it very easy to take a 3D shape like this and, for example, calculate what's known as its surface area. So surface area. The surface area. And if we remember, so let's say if we're talking about surface area, let's say if we focus on this shape, just this piece here. So if I want to get the surface area of this, so it's the area of this, it's the area of the surface. So for example, area is going to be length by width. So if we take this, just this piece here, so we can see that it has a width of 3 centimeters and it's, sorry, width of 7 centimeters, should I say. So this would be 7 centimeters. So we can see that here. And then this length is 3 centimeters. So the area inside here is going to be 3 multiplied by 7, which is equal to 21 centimeters. So what we can say then is that this piece here has a surface area of 21 centimeters. Now in order to get the complete surface area of this box, let's say, what I need to do is I need to calculate, I need to first of all break it up into its net, into its net, which looks exactly like this here. And then I want to calculate the surface area of each part of it, and then we can add them all up. And that gives me the surface area of the entire 3D shape or the solid. So what we can say then is that if this piece here is 21, so and remember, don't forget the units, it's 21 centimeters squared. So if this piece is 21 centimeters squared, then this piece down here is also 21 centimeters squared. So this is also going to be 21 centimeters squared because it has exactly the same dimensions as this. Now, if we have a look then, so this piece here is going to have the same surface area as this piece here. Okay, so if this is 5 centimeters from here to here, then from here to here is 7 centimeters, and we've already worked that out here as well. So this is 7 centimeters. So therefore the area of this piece here is going to be 5 multiplied by 7, which is equal to 35 centimeters squared. Okay, so therefore if this is 35 centimeters squared, then this is also 35 centimeters squared. Okay, so that's that surface area there. And then if we take this dimension here, so we have this here. Maybe I might use a different color than that. That's more obvious. So let's go with this one here. Okay, so if we take this one here then, so again the dimension here is 3 centimeters, and then this is 5 centimeters. Okay, so from here to here, and this one are exactly the same. So if I get the dimensions, for example, of this, which is 5 centimeters multiplied by 3 centimeters, so it's 3 multiplied by 5, which is equal to 15 centimeters squared. So therefore, if this is 15 centimeters squared, then this is 15 centimeters squared as well. Okay, so 15 centimeters squared, and then we have 15 centimeters squared. So now we've calculated, let's say, the area of each surface. So now what we want to do is we want to get the total surface area of this solid. And how do we do that? We just add up all of these individual sections' surface areas. So what we can do then is we can take all of these parts. Okay, so we've 7 centimeters. So what we can do is we can take all of these individual sections and we can add them up. So for example, we have this 21 centimeters squared here, this 21 centimeters squared here. Okay, so we can add these and we can add it to the other ones. So this here and this here are the two 35 centimeters squared, and then this one and this one are the two 15 centimeters squared. So we can just plug these into our calculator and we can add them up. Okay, like so. And we can see then that our answer is 142. So 142 centimeters squared. So what we can say then is that the surface area of this solid here is 142 centimeters. So if we were to look at if we were to add up each of the individual surface areas. So these are what are known as nets of solids. And basically what it does, if you take a solid and you break it into its net like this, it just makes it easier then to kind of calculate the surface area, the total surface area. So this here is what's known as the total surface area. So total surface area. So let me just put that in there. So this here is what's known as total surface area. It's the surface area of this entire solid. Okay, so that's nets of solids, and this is what's known as calculating the total surface area.